Hello. Now that we've put a number to your ability for series and parallel circuit calculations, we're looking at series-parallel circuits, also known as complex circuits, also known as combination circuits, um, and it's like they got married. Okay, so you have some aspects of series and some aspects of parallel. So we're going to start with some examples. Alright, so take a look at this circuit right here. From ground, we've got the battery, first resistor, then we have a branch, second resistor, third resistor, back to ground. So it's going to flow all the time. Alright, so if you just look at this left side, this looks like a series circuit. I'm not going to cover it up this side, but if you cover it up this side and just look at the left-hand side, it would look like a series circuit. If you look at the right-hand side, and cover up the left-hand side, this looks like a parallel circuit. Right when it branches, it becomes a parallel circuit. So everything you know about series circuits is going to apply on the left-hand side. Everything you know about parallel is going to apply on the right. So we can take this line right straight down. Series land, parallel land. Alright, so current. Throw a screen up here. Alright, so if we know the total current is 6 amps, and we know the current through I3 is 4 amps, what's the current at the second resistor? What's the current at the first resistor? Alright, in a series circuit, what do you know about current? Yes, it is constant. So write 6 amps here, constant. Make a little note to myself. On the other side, parallel circuits. What do you know about current in a parallel circuit? Well, the 6 amps comes in and then it splits. 4 goes down here, so how much would go up here? So you can do 6 minus the 4, leave 2 amps for the top. Alright, that's the first one. Look at the next one. Still the same diagram, so series on the left, parallel on the right. This time we know 10 amps goes through the second resistor, 4 amps goes through the third resistor. They want to know total current, and they want to know how much current goes through I1. Alright, so remember total current in a parallel circuit, it would add up. So 10 plus 14, so the 10 plus the 4 would get me to 14 amps. It's the total current, okay? 14 amps comes out. In a series circuit, it's constant. So I can fill in 14 amps there. And then it's going to split. 10 goes up here, 4 goes down there. Look at another example. Total current, they don't give us. They give us 8 amps through the first resistor, 4 amps through the top, question mark through the bottom. Alright, so in a series circuit, current is constant. There's no place else for it to flow, so it's constant. So we can fill out 8 amps here. 8 amps is going to come over, and then on the parallel side, we know it's going to split. If 4 amps goes up here, we've got 8 minus 4, or 4 amps to go down that way. In this case, the resistances will be the same. Alright, I think we have one more. There it is. Alright, so same diagram, series parallel, 4 amps total. So we know that in a series circuit, current is constant. So we can fill out 4 amps here. And then how's it going to split when we go to parallel? So we don't know anything about this, so this is cannot be determined. Cannot be determined, which is one abbreviation for CBD. Alright, so that's current in a series parallel circuit. Let's take a look at next page. Voltage in a series parallel circuit. So same diagram. Left hand should look a lot like a series circuit to you. Right hand should look a lot like a parallel circuit. Throw a shade up, keep things under control. Alright, so voltage at E1, 10 volts. Voltage at E3, 18 volts. They want to know the total. They want to know E2. Alright, so voltage in a parallel circuit is constant, so you can write 18 volts here. Okay. So 18 volts on this side, 10 volts here. The total, we're going to add them up. 10 plus the 18 gives us 28 volts for the total. So that should be in red. 28 volts. Alright, so 28 volts, if it dropped 10, you would have 18 over here, so that's why we add them up to get the total. If we have 24 volts total, we don't know this, we know 6 volts is going through E2, and we want to know E3 also. So voltage is constant in a parallel circuit. If we know 6 volts goes through E2, we know that 6 volts is also going to have to go through E3. Alright, 6 volts is dropped here. We can do, change it to red, 24 minus the 6 gives us 18 volts right there. 24, 18, 6. Another example, 24 volts total, 10 volts at E1. What's it going to be at E2 and E3? Alright, because this is constant, this is knowable. Alright, so if I have 24 volts, I drop 10, I've got 14 left for the parallel side. I've got 14 volts. I know it's constant throughout the... Don't split it up. Don't give me 7 and 7. Alright, another example. 12 volts here, 12 volts here. What's going to be for E1 and ET? Alright, so this is a CBD problem. Okay, cannot be determined. I would need one of these. I know the total is going to be more than 12. I don't know how much more than 12 because I don't know a voltage for E1. Oh, one more problem there. If I just know 12 volts here, what can I fill out? Well, I can fill out this side because I know current is constant. But these still are going to be CBD, cannot be determined. Cannot be determined. So that's voltage in a series parallel circuit. Resistance in a series parallel circuit. So again, left-hand side should look like series. Right-hand side should look like parallel. And if we know all the resistances, R1, R2, R3, can we find the total resistance? Yes. So remember, resistance in a parallel circuit. So we have to do the 1 divided by parentheses 1 divided by H plus 1 divided by H to find the total resistance for this branch of the parallel circuit. And calculator. I'll run through the calculator. Alright, so 1 divided by parentheses 1 divided by 8 plus 1 divided by 8. Oops, 8 close parentheses equals, so we get 4 ohms total over here. Alright. So if I know I'm waving with my hand, that's not working. So if I know 4 ohms is what this branch acts as, and 10 ohms is what this resistor acts as, I can do 10 plus the 4 and get 14 ohms total. Let's throw up the shade. Alright, so calculate the resistance on the right side, add it to the resistor, and get total. Alright, so here we know the total, we know the two R2 and R3, looking for R1. So again, we need to find what the total resistance on the parallel side is. So 1 divided by parentheses, 1 divided by 4, plus 1 divided by 12, close parentheses, 1 second equal, bring back the calculator, 1 divided by parentheses, 1 divided by 4, plus 1 divided by 12, close parentheses, equals, so this is 3 ohms. So 3 ohms on this side, loss of resistance here equals 20, so I can do 20 minus the 3 and know that this side resistance has to be 17 ohms. Alright, if I know 20 ohms and 17 ohms, can I find R2 and R3? Alright, this should look a lot like the one we just did, but this ends up being cannot be determined. Okay, it could be 4 and 12, but it could also be a lot of other things. So we can't say with certainty what R2 and R3 is. I can say with certainty it better total 3 ohms when I do the formula, but I can't narrow it down. 1 divided by R2 plus 1 divided by R3. I know this has to equal 3 ohms, but I can't say specifically what R2 and R3 have to be. Alright, another example. Let's get rid of that shade. Alright, so if I know the right hand side, then I find the left hand side. So I could put this through my formula. 1 divided by parentheses, 1 divided by R2 plus 1 divided by R3. Call the calculator. 1 divided by parentheses, 1 divided by 4 plus 1 divided by 8, close parentheses, equals, it's not pretty, 2 and 2/3, make it a fraction, ohms. Alright, if I was to round, 2.67 ohms. Alright, 2.67 ohms on this side, but I don't know the side, so I can't know the total, so it can't be determined. And this would be 2.67 plus whatever R1 is, but that basically can't be determined either. Alright, so that's resistance. And turn the page. We have a circuit. If you look at this side, this should look a lot like series. Only one path for electrons to flow. This side should look like parallel as soon as you branch. Alright, they give us 36 volts total, 4 amps total. They give us R2 and R3, and they want everything else. And I'm going to bring this up. So we don't have much to work with on the parallel side. So over here, series side. Series is current is constant, remember, so we can fill in the 4 amps here. So you have to start with that. The other thing you could start with, we could do power. Remember your triangle, PIE. So we have I and E, so we can do 4 times 36. 4 times 36. 4, carry the 2, 144. Power is measured in watts. So you could start with either that one or that one. We can do them both. We could also use EIR and find the R total. EIR triangle. And we have 36 and 4. So we can do 36 divided by 4, or 9 ohms here. This isn't an easy problem. 9 ohms and 6 ohms. So I know this has to add up to 3, but it's not easy to solve for R2. So we'll come at it through voltage and current. All right, so what else do I know? And what else can I calculate? So in my EIR triangle, I can do I times R, so I can do 4 times 6, so I can get 24 volts up on top. 36 volts total, 24 volt drop here, which means I have 36 minus 24, or 12 volts on this side. Don't split it up, it's constant in a parallel circuit. So 12 volts, 12 volts. Go to the end, you can use your EIR triangle. E divided by R, 12 divided by 12. You might not even need a calculator. 1 amp. We've got all but one current with 4 amps total. So 4 amps comes out, 4 amps goes through here, and then 4 amps splits up. If 1 goes to the bottom, R3, how many goes to the top? So we can do a 4 minus 1. So I know 3 amps has to go there. You've got E and I. Can you find R? It's a triangle. E divided by I. 12 divided by 3 will get you 4 ohms. And then we should check this. So 1 divided by parentheses 1 divided by 4 plus 1 divided by 12. And calculator helps in this case. 1 divided by parentheses 1 divided by 4 plus 1 divided by 12, close parentheses, equals, so we know this equals 3 ohms, which is what we wanted. 3 plus the 6 gets me to the 9, so I'm confident with this answer. Alright, so this is what we're going to be practicing over the next few weeks. Thank you for watching.